take a look at an example of a word problem that we can use different versions of the quadratic equation to help us solve. So in this particular word problem, in this example, it tells us that a ball has been kicked from a ledge. Its path is given by the relationship of h is equal to negative 1.3 times t squared plus 5.2 times t plus 6.5. Okay, where h is the ball's height above the ground in meters and t is the time in seconds. So a couple things to note right off the bat. The equation that's given to us is actually given to us in standard form. So y is equal to ax squared plus bx plus c. Okay, and standard form is really helpful for determining the direction of opening of the parabola, but also tells us what the y-intercept is going to be. It also, in this word problem, gives us a description of what the situation should look like. So the ball is kicked from a ledge. A ledge is kind of like a cliff. So let's say that that's the cliff. And let's draw in our happy little soccer player. There he or she is, and clearly my skill at the drawing stuff has not improved at all. So they're going to kick this ball. We'll make the ball green. Okay, and we know that the ball is going to be kicked, and we also know that the ball, based on the A value, is going to be heading down. Okay, so the ball is going to be going down in a parabola. Okay, now where h is the ball's height above the ground in meters and t is the time in seconds. So let's assume that for now that the ground is over there. Okay, so this is the ground somewhere. Okay, so this is what we know. We have someone standing on top of a ledge. They're going to kick the ball, and it's going to land on the ground at some point. Okay, so part A says, what is the initial height of the ball? What's the starting position of the ball? Because if we were to draw this as a coordinate system, okay, we would actually have the initial position would be where the ball is relative to all of the other pieces. So we would say that the ground is actually the x-axis, and that the edge of the cliff here, that's our y-axis. So we could actually draw this piece all the way through. Okay, so if we draw in our y-axis, okay, so the ball is on our y-axis, and this here would be kind of our origin. Okay, so we know that the ball is starting at an initial height of some point, and because the equation that is given to us in standard form, we can determine straight away that the c value is going to be the y-intercept. Okay, the y-intercept is also known as the initial starting position. Okay, and so when you ever see the term initial, the initial height, that means what's the y-intercept. So in this particular instance, the y-intercept is going to be 6.5 meters. Okay, so we know that it's 6.5 meters because it tells us that in the original equation. So we know that the ball is going to be somewhere over here. Okay, and so the ball is going to go through a certain flight path. So as the ball is kicked, it's going to be going up, and then it's going to hit the ground. Okay, and so we want to figure out, when does the ball actually hit the ground? At what time does the ball actually hit the ground? And to do that, we need to make use of the equation, and we probably have to manipulate it a little bit. So the original equation that we were given is that h is equal to negative 1.3 t squared plus 5.2 t plus 6.5. Okay, now we can factor this, and we have to factor it because the a value is not positive 1. So if we're going to factor this, what we need to do is actually divide all three terms by negative 1.3, or by the a value. When we do that, we obviously have to carry that negative 1.3 down with us. It doesn't just get lost. So h is going to equal negative 1.3 And then we'll end up with t squared. 5.2 divided by negative 1.3 is negative 4t. And 6.5 divided by negative 1.3 is equal to negative 5. Okay, and so now um, we have a trinomial that we can factor. Okay, so if we go through and we're going to factor out this trinomial, we're looking for two numbers, two numbers that multiply to negative 5 and that add to negative 4. Okay, so if I do 1 and negative 5, that multiplies to negative 5. And so that's great. And when I add those two things together, they add to negative 4. So in factored form, this is going to be negative 1.3 times t plus 1 and times t minus 5. Okay, so now we've put this equation into factored form. Now the great thing about factored form is that we can use it to determine the zeros. Okay, so the zeros for this particular situation are going to happen at negative 1 and positive 5. Okay? Ooh, I don't want that. Okay? Now, if you have a situation where we have someone kicking a ball off a cliff, does it make sense that you can actually have a zero at negative time? Okay? Well, no, it doesn't. Because this parabola is only part of a parabola. The rest of the parabola, if you were to continue it on, would end up going back this way. But this doesn't actually happen. We're not going back in time. So because you cannot go back in time, okay, the ball can only ever travel in one direction. And so when the ball is traveling, it's going to impact the ground right here. So if you were to extend out this ground line invisibly, you would have a 0 at negative 1 and the other 0 at positive 5. Well, because you can't have negative time, there's only one logical answer. So in this case, when the ball hits the ground, it hits the ground after 5 seconds. Okay, because t represents the time in seconds. Okay, so after 5 seconds, the ball has hit the ground. Two other things we want to know. It says, what's the maximum height? And so when did the maximum height occur? And what is the maximum height of the ball? So we're actually looking for the vertex. Okay, so we know that this ball is going to actually have a vertex of somewhere over here. Okay, we got to figure out where that is. So we got to figure out the time that that happened at. Okay, and we also need to figure out the height of that particular event. Okay, so if we can figure out the height and the time for it, we've got the vertex. So let's just go through and solve the vertex. So we know that because we have the zeros of negative 1 and 5, we can figure out, first and foremost, and I'm going to do this over here because there's more space, we can figure out the axis of symmetry. So our axis of symmetry is the average between the two zeros. So the average is going to be negative 1 plus 5 divided by 2. That's going to give us 4 divided by 2. That's going to give us 2. So the x value happens at 2. Okay, so in this instance, when the maximum height occurs, well, it happens after 2 seconds. Okay, because the x-coordinate of the vertex always tells us when something happens. The maximum height is determined by the y-coordinate of the vertex. And now that we have the x-coordinate of the vertex, we can go through and we can solve for the y-coordinate of the vertex. So what I'm going to do is I'm going to take our equation, or one of the equations. So I've got negative 1.3 times t plus 1 times t minus 5. Okay. So what I'm going to do is I'm going to substitute in our x value, or our t value. In fact, I should change this to t just to make it less confusing for us. Okay. So this is time in 2 seconds. So if I substitute in, I get h is equal to negative 1.3 times 2 plus 1 times 2 minus 5. So h is going to equal negative 1.3 times 3 times negative 3. So my h value is going to be negative 1.3 times 3 times negative 3, and that's going to equal 11.7. Okay, so my maximum height is going to happen at 11.3 seconds. Okay, and so what this allows us to do between the t value and the h value, that tells us that the vertex is actually happening at 2:11.7. Okay, so after 2 seconds, the ball is at its maximum height, which happens to be 11.7 seconds.